Right, gents, this isn't a talk on how to program nanos. It's not, because that's the province of the special interest group. We've covered the hardware of nanos in some detail as a joint session between 4 area groups. We also covered the IDE. So today is just answering basically 2 questions that people have raised. The first one was, somebody came to me and said, I'm having a terrible time. I'm looking to buy one, but when I look at the adverts, they all seem to be contradictory and confusing. So it's just a matter of what to look for in a nano. And then the second part is to do with programming. Some people have had problems trying to work out what to do with bootloaders and programming and so on. So I'm hoping to cover these 2 in the next short while. So if we start with this, the left-hand side is the specification of a nano as said on Wiki. The right-hand side is the specification of the nano as outlined by Arduino themselves. And there are obviously common points, but there are some confusions even in there, even before you start looking at the actual product. They both use a microcontroller called the Atmega 328. We'll look at that a little bit more detail later. They both operate at 5 volts. But I've underlined some in red. You'll see, for example, that the Wiki says it runs up to 20 volts input, whereas the Arduino says 12 volts maximum. You'll see that the Wiki says you've got 14 digital pins and 8 analog pins, which is kind of true, except you can use analog pins as digital if you wanted to, but you're only allowed 8 to be used as analog. And then if you look at the Arduino spec, it says it's got 22 digital and 8 analog and 6 PWM, which will give you the impression that it's got, what, 36 pins. Again, the 22 includes the 8 that could be analog. So they can be a bit confusing. And then the bootloader section. The flash memory is the part of memory that stores the computer program, the actual application. And they're both correct in saying that the Arduino Nano has got a 32K block of memory. But the Wiki says it needs 0.5K for the bootloader. The Arduino says it needs 2K, and they're both right. And I'll explain that a bit later. But it can be confusing before you even look to buy one. So what I want to do now is just look through some of the adverts that you see in places like eBay and Banggood and so on, and clear up what it's about. Before we get there, you should be aware that the Atmega chip, which is the basis of the Arduino and the Uno, come to that, is available, as you can see there, in bit format, just with ordinary pins that you plug into a socket, an IC socket, or it can be in surface mount. When you get it on the Nano, as you can see there, it's the quad surface mount chip that's used. So the Arduino Nano isn't some special thing. It's just a board that happens to have an Atmega microcontroller on it with add-ons. It's got a voltage regulator, got LEDs for, it's got connections for programming it. You'll see the USB socket, for example, up there. So it's got add-ons, and all the pins are taken out conveniently. You're not trying to solder onto these horrible little tags on the side of a surface mount. It makes it convenient for users. So that's all we're talking about. They're based on Atmega 328s, which I'll look at a bit later. You don't have to use the nanos. I used nanos initially for the EasyBus output modules, but you'll see there that we're using 328 Atmega chip without the nano, mounted on a PCB with its own voltage regulator and its own pins and its own crystal and so on. The right-hand side, again, is using a Mega 328 chip, not the Nano, just the chip itself with all its surrounding bits. That's to make up the new EasyBus controller. But back to the Nano itself. Which one? That's an extract from the Arduino's own website. And you'll see there's various flavors. Some are for Bluetooth, some are for Wi-Fi. The one that's at the top is just called the Arduino Nano. That's the one that's most commonly used. That's what people are looking for in general, unless you need special use of Bluetooth or Wi-Fi connections and so on. You'll see it's different in shape from the rest for a start. It doesn't have aerials and so on, but on the right-hand side, you'll see it's got a connection called ICSP. There's a 6-pin connection at one end and a USB connection at the other. And that's the basic outline you'll see with some small changes when you look at adverts. So let's look at a few adverts and try and unpick it a bit. That's the Arduino as made by Arduino themselves. The official, as it were, Arduino, and they're expensive, 17 quid, including VAT. But again, you can see how easy it is. All the pins are down the sides for easy connection. You can plug it into a female header strip and connect anything you want to afterwards. So it's convenient to use, but it's expensive. So that brings us on to the idea of clones or compatibles. You'll see lots of adverts for nano compatibles, commonly called clones. Let's not get too critical. Clone in your mind suggests like some pirate piece of equipment, some sort of knockoff and so on. But in practice, the Arduino Nano is an open source hardware. In other words, you're allowed to copy it. And that's what compatible means. It's not actually made by the Arduino people. It's made by other people that matches in most respects the compatibility with a Nano itself. However, because it's open source hardware, there could be some changes. You might find some component changes. In fact, you will in most compatibles. You might find LEDs in different places. And if people come back to me and say, no, this Nano's got 4 LEDs and that one's only got 3, what's going on? Or they're in different places. You even get different sizes. I actually ordered up these boards when I was young and naive. Now I'm old and naive. But you can see the difference in size is substantial, because what they've done is the Nano itself has got components on both sides. The ones that you see on top here, but if I turn it over, you'll see there's more chips underneath as well. Whereas this board has put everything on top. So that's the WeMOS version. It does the exact same job, but it's a different size. Still works. That's exceptional, really. But just to know it's there. More likely you'll find this in an advert. So now we can see what it says. We're happy with the Mega 328 idea. We know that that's the main chip that's in it. There are exceptions. Sometimes you get a separate chip, but very uncommon. So most of them will have Mega. I should say, you'll find most of these adverts put lots and lots in their description. Because what they're hoping to do is, if you do a search for the Mega 328, you'll find their advert. If you put in a search for Nano, you get their advert. If you put in a CH340, you reach them. So they put in lots of details, which you might find confusing. But this is an ordinary compatible. In other words, it's going to work. You can plug it into the same set of header strips and program it the same way, and it'll function the same way as if you'd bought the £17 version. And you get it for only 4 quid. We can tell right away that it is, even if it hadn't said compatible, we would know that it's not the genuino. It's got a CH340, which is a chip that is cheaper than the ones used in the Nanos, the official Nanos, and therefore is very common in compatibles. Everything else in there works on 5 volts, 16 megahertz, is per the spec. So although it says a lot, there's no mystery there. This one, again, tells you it's got a 328. It tells you it's a nano. It tells you it's 8-bit. We'll come to that a bit later. This one tells you it's got a bootloader already on it. In 90% of cases, they've all got that anyway. That's not an exceptional thing to have. There are occasions where you might buy one that's not got a bootloader. We'll come to that. It's a separate issue. But they're just letting you know that if you're a beginner, they're reassuring you that it's already coming with that, and it makes it easier to program without having extra tasks to perform. Next advert. They've called it a control module, which is, okay, it's another description of it. It's not particular, but it's, if you look at the side here, it's a standard nano. It's got a 328 chip in it. There's the 6-pin at one side and the USB at the other. The geek kite, one of the members found confusing. It's just a brand name. It's not some special hardware or firmware. It's just a brand name. Here's one again, very similar. Tells you what the chip they're using, tells you what processor they're using, what microcontroller. They call it a microcontroller, which not strictly accurate. It's a board that contains a microcontroller. The microcontroller is the Atmega 328. It's really a board for experimenting rather than a microcontroller itself. But again, you can tell it's okay. It's got the USB and it's got the 6-pin header. This one is a bit different. It says it's a version 2 compatible. Right. There are version 2 and version 3. You probably saw some earlier ones that were version 3. This is a version 3, but works as a version 2. Whatever that means, we'll come back to it shortly. This is a module board, different description again. The welded just means that it comes with the pins already soldered. That one comes with the pins separate. Most of them come that way, and you just solder them in yourself. This one has got them translated as welded. Soldered, I would think, is probably more likely what's happened there. This one, there you go, a different chip in it. It's still the Atmega range. It's still a nano compatible. It's still a development microcontroller, but it's using a 168 rather than a 328 chip, which is just a question of its memory size. We'll look at the difference in a moment. So we've come to a whole bunch of different descriptions. And finally, this one is going to charge you, what, 30 quid for that one, but you get a USB cable. As long as you have got a mini B USB cable lying about the place, you can connect straight into the USB socket of all the compatibles. And then there's this one, which is a bit confusing, I would agree. It says it's compatible with a Nano, but that doesn't mean it's a direct replacement for the Nano. It's got the Atmega 328 on it, works at 5 volts, 16 mega memory. It is compatible with a Nano in terms of it's got the 328, but you'll see it in the picture there. There is no USB connection. So don't think you're going to buy that and just plop it in place of a Nano in your projects, because you have to program it differently. So to say it's compatible with the Nano is true and not true. Right. So you saw there that most of the chips were said 328, but some said 168. How do you know the difference? Mostly, if you've got an eyeglass, you simply look at the chip itself, and it'll tell you on it, it's a Mega 328P. Both of them use the same chip processing power, the same CPU in it, and so on. The only difference is how much memory the two chips have. So if you write a small program, it doesn't matter whether you program it in a 168 or whether you program it in a 328, it doesn't matter. If you're going to write larger programs, it might overflow the capacity of a 168 and you have to use a 328. It's not a problem nowadays because 168s are becoming less frequently to be bought anyway. So what does it all mean? Well, a 168, as you can see, just the 16 part means it's got 16K of program space. The 328 means it's got 32K of program space. The part that says 8 just means it's 8-bit processing. In other words, the CPU in there handles 1 byte at a time when it's moving stuff around. And then the P just means pico power. It's capable of working at very low currents in sleep mode and stuff like that. Now, the version 2 and version 3, that's where they come in. Version 3 is talking about the 32K model. And the 2X, so it could be 20, 21 or whatever, is talking about the 16K model. That's why earlier it could say the 328 was version 2 compatible. It can do everything that the 168 can do and still have 16K of memory spare. That's the only difference. So hopefully that unbundles some of the specifications. As long as you see that it's got a 328P in its specification, as long as you see it's got a USB at one end and a 6-pin connector at the other, you're pretty certain that you've got yourself a proper Nano when you're looking at the specs. So that covers selection of trying to buy one. The next question people raised with me was the question of programming Arduinos. So there are 3 approaches to programming a Nano. The most common one is using the USB connection. And that's got on board a chip called the Ftdi chip, which translates from USB messages into TTL levels for operating inside the chip itself. There's also one called the UART, there's one called the SPI, which we'll look at briefly, but mainly we're looking at the USB. We won't look at the whole circuit, just to let you see that there's the Arduino Nano on the left-hand side, or the Mega 328 on the left-hand side. The right-hand side, you'll see a marking called USB, and down at the very right, you'll see the USB socket. So it comes in on the right-hand side there from your USB cable, gets translated by that chip that's called the FT232 into serial to feed into that Mega. But up the top, you'll see one called ICSP. That's the SPI connection. So you can program an onboard Mega and a Nano 2 ways. Most people are going to use the USB, but there are occasions you may have to use the SPI. So there we have, again, top right, SPI connection, and then the Mini B on the most common way. Now, the Ftdi chip I mentioned is the bit that you see underneath the Nano. That's the most common chip for official productions. Bit expensive, so compatibles or clones use one called the CH340. You saw that in the adverts we looked at earlier, and that would sit in the place of the Ftdi there and do the similar job, converts from USB into serial. And that chip is very handy for bootloading, which is an issue we'll explore next. We've had a number of questions about this. You decide to make the board a Nano. You've written your program. It's now time to program it. You set which port you want to write to. You decide which board you want. You choose Nano. And at that point, you're given 3 options. So we've now a bit better appreciation. A 168 means it's the only 16K of memory. So if you've got a 168 Nano, that's the option you choose. If you've got a 328p, then you get 2 options, the new and the old bootloader. And what you do is you try one, doesn't want to try the other. It's a simple way of working. But what does a bootloader mean? Well, when you switch on, put power to a Nano, it's got 2 options. It could be running something that's already on the Nano, some program you already got on it, the sound player for talk's sake. Or it might want to have a new program put onto the Nano. So how does it know the difference? The Nano is just sitting there. How does it know whether it's meant to run the existing program that's already on in the memory or put a new program into memory? And it does it with a bit of software that sits already inside the Nano, the bootloader. So the bootloader's job is to say, keep looking for a short time at the incoming stream of serial coming in from the USB. And if nothing's coming in after a certain amount of time, you're not trying to program it, in which case you can run the existing program. If you detect signals coming in the serial, then you know they're going to overwrite any existing program with a new code. So there's the memory you get inside in that Mega 328 or a 168, depends the size. So you've got a block of memory, say that's 32K, but some of it is reserved for the bootloader if you go down that route. You'll see you've also got other blocks of memory, one for storing the variables, one for storing values once the power goes off. Things like you use, for example, in easy points or whatever, or Servo 4, where you're actually saving values inside the memory. So you've got 3 blocks of memory, but the main block that holds the program also has a piece called the bootloader. And it's its job, power up, check whether you're trying to program it, or if not, just run the existing program. So you connect your computer to the USB port. The computer's job, if it's trying to program, is to convert what's coming in from the computer in the USB, use either the FTDI or the CH340 to convert it into a serial format that can be written to the flash, which is that whole section called Application and Bootloader. And the job of the bootloader is to check whether something's coming in or not. If nothing's coming in, automatically runs the application. If it senses there's a programming stream coming in, then what it does instead is it loads into the top part the new application. The bootloader itself then takes up some memory. The old bootloader and the new bootloader. The old bootloader used 2K of memory. And you probably saw it way at the beginning when we looked at the spec. So it allocated 2K, anything above 2K could be the actual application, anything below it was reserved for the bootloader. They then wrote an improved and faster bootloader than the old bootloader. And although it's smaller, it still sits in that 2K section. So although it's faster and smaller, it doesn't relieve the need to, we can't recover some of the bootloader section. And that's why the earlier spec, one said half a K and the other said 2K. They were both correct in that sense. So now we know what the old bootloader and the new bootloader is about and why you make those choices. Now, there are other ones that are kind of Nano compatible, like the Pro Mini. It comes, by the way, you'll see in a 5-volt flavor and a 3.3-volt flavor. More and more people are moving to 3.3 because that takes less current and is compatible with lots of other devices that also run in 3.3 without any voltage translations. But in both of these cases, there is no USB connection. Makes them smaller, but how do we program them then? Well, that's where the USB isn't an option. There's another one that converts from USB to TTL to serial called the FT232. That's the chip that you often see on board. Remember I showed you underneath a Nano, you saw the little chip, the FTD. You can get it on a board separately. So it's got a USB, where my thumb is, and the way in, and the way out, it's got the TTL. And therefore, you can then plug that straight into the end of one of these Pro Minis and still program it. So that method is available to you. Also, if you wanted to, with the Nano itself. Although it's not got a connection as such, you can make your own jumpers across and use this, say, USB in that side and program that way. This is something that I'm still working my way through. It's using a larger Arduino chip than the 328. And it's going to hopefully be a touchscreen version of the EasyBus controller. But to program it, I've had to use, as you see here, the 232 serial adapter. USB coming in from the right-hand side, plugs in into my board, and it's taken from there to the chip itself to program it. So it depends whether you're going to program through the USB or through the serial connection. And the third way is if you use the SPI connection. As you saw, that's where the 6-pin header comes in. We've got a 6-pin header. That's me using it. USB come in the right, come out in the left, and connecting to this board. This is the back side of the new EasyBus master that I showed you earlier. So I'm programming that direct. The benefit of this method is it doesn't need a bootloader. In other words, you can recover that 2K. If you're short of memory, you can recover it. Don't use the bootloader, don't use the USB, but use the tiny ISP. Bit more complicated because you've got to do things like this. For those of you who are used to programming with PICs, you'll know that in the pragmas and so on, you can say, make it run at a certain speed. You can set a bunch of parameters that should work in your code. But when you're programming this way, you have to use what they call fuses, which then set the speed and other factors. So it's a more manual job, but the benefit of that is that you are able to program directly to the chip without the bootloader and recover the bootloader space. Or if you get a chip that you've bought that doesn't have a bootloader, you can put a bootloader on it yourself. And that brings me to the last point that was been raised. Some people have bought Nanos and they don't blink. Most providers, when they sell you a Nano, they put on a program called Blink. You put the power on and you'll see the LED flashing. And that tells you it's got a program on it that will flash a LED. If it doesn't have a light on it, people assume it's broken. It's not. It may simply not have been programmed with the Blink. Or it might not even have a bootloader on it. The other possibility is it blinks, but you still can't program it. Why is that? Because they've put the Blink programming on using the SPI, in other words, no bootloader. It's used up the whole of the memory space, not a whole, but it's overwritten the memory space. And therefore, when you want to program it, it won't program because it's not got a bootloader. I know a number of people have thrown these in the bin thinking they were faulty when either there's been no bootloader or it simply has been programmed with a blink in the first place.